Chord of contact for the hyperbola. So we looked at the chord of contact for the ellipse and we saw it's very similar idea, pretty much exactly the same as the tangent to the ellipse, and it works exactly the same as the hyperbola. Okay, so you've got an external point T, alright, that goes to the tangent of the hyperbola at 2 points, and then the chord of contact is the chord that goes through those 2 points of contact. Okay, you can have it on opposing sides depending on where T is, or the tangent can be on the same side of the hyperbola. Okay, so if you put position P in a spot where you've got the tangent there, okay, of course it'll be sequence for this one, depending on where they are, okay, and the gradient, etc., or it won't go through the other side at all, okay, depending on the positioning and the gradient. Right, so that's that. So very similar to what we've done for the ellipse, so the equation of the chord of contact of the tangent to the hyperbola. An external point is given by that. Okay, because the tangent at P, so going back to what we've done earlier lesson, so it'll be x1 x over a squared, take away y1 y over b squared is 1. So that's the format of the equation of the tangent in Cartesian form for your hyperbola, which you've done last week at some point. And at Q, you've got x2 x over a squared, take away y2 y over b squared as 1. Okay, and then from that external point must satisfy the 2 tangent. Okay, so T, x naught, y naught, satisfies both equation of tangent. Okay, and if it's satisfied both those points, and then the chord of contact goes through the contact point of the tangent, okay, so it must also satisfy the chord PQ. Okay, so there's one benefit with this formula. It is exactly the same as your tangent for both your ellipse and hyperbola. That will help you remember that one. Okay, so therefore the external point must match with that. Alright, so from a point T, negative 6,1, 2 tangents are drawn to touch that hyperbola. Find the equation of the chord of contact and determine the coordinates of the point of contact. And lucky you won't get to go through my second question, which is absolute. Let's call it joy of excitement with algebra. Right, so from a point to tangent, touch the hyperbola. So find the equation of the chord of contact. Okay, so chord of contact has the equation. So x naught x over a squared, take away y naught y over b squared is 1. Right, so what's a squared and what's b squared? Hey, what's the problem? Is it 1? No, but I'll need this side. To get A's and B's, I'll need the right hand side to be 1. Alright, so x squared on 36, take away 4 on 36 becomes 1 on 9. Okay, you need to set that right hand side equal to 1. When you do that, then you'll have your A's and B's. Right, so the external points are negative 6x on a squared, which is 36. Take away y naught y over 9 is 1. Negative x on 6 take away y on 9 is equal to 1. Okay, so we need the equation and the intercepts points. So y on 9 is going to be negative x on 6 take away 1. Yep. So it's going to be 3 over 2 x take away 9. Okay, and the reason why I wrote it in that form because we need the intercept points. Okay, so I've got an equation of the line, and now I've got the equation of the hyperbola up there. So, yes, sorry, thank you. Alright, so I'm going to substitute it back up into the original equation just because it doesn't have fractions in there already. So, just number 1, and then back up to my original equation, number 2. Okay, so put that in there. X squared take away 4y squared. Equals 36. Right, I'm just going to make it a bit easier for myself. So it'll be negative 3x take away 18 all over 2, all squared. Because if I square that 2 here, it's going to cancel out the 4 out the front. Okay? So that way I don't have to do any denominators. Right, so x squared take away. So the negatives, they need to have your brackets. So we've got 9x squared. I probably could have taken the negative out there. Anyway, so 18.3 is the same as 9 times 6, which is 54. 108. What's that n squared? $318 squared. 300 and something 6.
324.
I know.
324.
Can't be. Oh, yeah. Yeah. Hey. Alright, so 324, negative 324 take away 36. 324 and 36 makes 60. So 8x take away 108, 8x squared take away 108, plus 360 is 0. Right, is 8 a factor of 108 and 360? $96, 88, 96, 104, no. Right. So we could take obviously a factor of 2 or maybe 4 even. 100, 104, 108. Yep, factor of 4 would work. So 54, 27, 360, 180 and 90. Alright, so unless you can pick your integers that work there, or it may not necessarily be integers, it won't be, so you have no choice to use your quadratic formula. Okay, so when you use quadratic formula, you'll have x equals, let's call it x1, and x is x2. Alright, and then you have to substitute back into y, which was number 1, to get your 2 corresponding answers. Okay, so x equals x2. Okay, so you can finish that question up. So 6, 0 is one of them, and this is just from me, GeoGebra this morning. Negative 7.5, 2.25. Okay, finish that up. Right.